So 2020, paper 1. The real number system. In the real number system, the inverse of addition is represented by subtraction, which is b. So one time that's a repeat. This is also a repeat. Given that f of s is 0, then that means x minus s is a factor. F of minus r is 0, then that means x plus r is a factor. And which of the following equations is true? So I'm looking for the x minus s and the x plus r. That's going to be A. P, Q, and R are propositions such that P, it is raining, Q, the sun is shining, R, there's a rainbow. Alright, so I've seen the answers. So one time as I read, I'm going to develop the statement, right? It is raining and the sun is shining, but there is no rainbow. So it will be and there is no rainbow. So P and Q and not R. So P and Q and not R. See? If log 4 to base A, log x to base A, log 7 to base A is 2, I'm going to use the law of logs for all three one time. I'm going to get log of 4x divided by 7 to base A is equal to 2. The value of x is, I'm going to get a squared is equal to 4x over 7, and 7a squared over 4 is equal to x. 7a squared over 4 or 7 over 4a squared. Answer is B. This is a repeat question. If I am not mistaken, A was the answer, but we'll still go through the working. We can plug in values in the calculator, or we can say 4 root x plus 4 root 3 root x over 48 is root 16 by root 3, root 16 root 3, root 3, oh, I put root 3 root 3, root 3 root 3, 16 is 4, so 4 and 4 cancels, 4 root x plus root x is 5 root x, so I was correct. Given that x and y are negative integers and x is greater than y, which of the following is true? So x and y are negative integers. So we have x and y. I'm putting this as 0. X is greater than y. So this is x, this is y. Minus 1, minus 2. Which of the following is true? So x squared will never be greater than y squared because x squared numerically is going to be a smaller number. X squared will always be less than y squared. This is also a repeat. D is the answer. Alright, this was a repeat question, and I believe it was negative a on 3n. So let me go back to the working. One time I will replace the inequality sign with an equal to sign, and I'm going to get 2x minus a all squared, take away x all squared is equal to 0. I'm going to get 2x minus a minus x into 2x minus a plus x, difference of two squares. 2x minus x is x minus a is equal to 0, and x is equal to a. And I'm going to get 3x minus a is 0. X is equal to positive a over 3. And we want to know which part this is greater than, right? Because of the inequality sign, it's greater than. So greater than for the positive is going to be here and here. It's less than a over 3 and more than a. So less than a over 3 and more than a. A is the only answer that gives me that. And we had a discussion about the word separating it, which is or. I would like to say and is supposed to go inside of there, right? P of x is equal to x squared minus hx minus 12h squared, and P of alpha is equal to 0. What are the values of h in terms of alpha? So if P of alpha is equal to 0, then we are going to get alpha squared take away alpha h minus 12h squared will be equal to 0. This is P of alpha. What are the values of H? This is a nice question. So I must make this a quadratic in terms of H. I could make it a quadratic in terms of alpha if I wanted to. So what I'm going to do, I'm going to solve for H. I'm going to throw the whole equation on the right hand side and have 0 is equal to 12h squared plus alpha h minus alpha squared. Now I'm going to use quadratic formula. A is 12, B is alpha, and the C is minus alpha squared. Quadratic formula says minus b plus or minus square root of b squared, which is alpha squared, minus 4ac all over 2a. This is going to be h minus alpha plus or minus the square root of, are going to get 48 alpha squared plus alpha squared is 49 alpha squared over 24. H is minus alpha plus or minus 7 alpha over 24. Minus alpha plus 7 alpha is 6 alpha on 24. And the next one is going to be minus alpha minus 7 is minus 8 alpha on 24. 6 could go into this 4, so alpha on 4. And 8 could go into this 3. And minus alpha on 3. The answer is A. If the range of f of x is equal to that, then the domain is, now I want us to be careful here, right? If they give us a function, the function will take us from domain to codomain. So from domain to codomain, but I will use range here because they mention range in the question. Domain to range. F of x is responsible to go in here. If they say the range is 3 over 2, 2, 3/5 and so on, to go back to my domain, I need f inverse of x. So let me go ahead and get what f inverse of x is. Y is equal to 2 over x plus 1. X is equal to 2 over y plus 1. Move the 1 across. X plus 1 is equal to 2 over y. Cross multiply. Y is equal to 2 over x plus 1. This is my inverse. Let me check and see what 3 over 2 plus 1 is. Jump on my calculator. I'm taking the first entry in my range, which is 3 over 2. 2 divided by, open brackets, 3 over 2 plus 1. Again, 4/5. It's supposed to be x minus 1. Right, so one time I see the mistake as I didn't get a answer that corresponds to one of the options. So instead of 3 over 2/3 plus 1, we're going to have minus 1. We get 4 as the first, not 4 as the first, 4 as a entry in the domain. The only one that has 4 as an entry in the domain is going to be C. But we can entertain the rest and see where is the C. Next one is going to be 2 divided by 2, take away 1. We're going to get 2 is the next entry. Then we're going to get 2 divided by 3, take away 1, which is 2 over 2, which is 1, and so on. So we can set in stone that C is the answer. Alright, so number 10, the sum of the squares of the roots of the equation is, so let's get alpha plus beta plus gamma, is minus b over a, alpha beta plus alpha gamma plus beta gamma is equal to C over A, and alpha beta gamma is equal to minus D over A. The sum of the squares of the root is alpha squared plus beta squared plus gamma squared. This is alpha plus beta plus gamma all squared minus 2 into alpha beta plus alpha gamma plus beta gamma. This is minus 3/4 all squared minus 2 into minus a half. Minus 3/4 all squared is 9 on 16. 9 on 16 plus 1, that is 9 on 16 plus 16 on 16, which is 25 on 16. The answer is D. Which of the following statements is true? So this is a question that actually pops up a lot in Unit 2 work as well. Exact same question. And I can't remember if it repeated in Unit 1 or Unit 2, but we'll still go through the explanations for each of them. Part A, if we set the summation of r squared, that is 1 squared plus 2 squared plus 3 squared, and I could keep going, right? I will just use the first three terms. Is this the same as 2 multiplied by 1 plus 2 plus 3? This is for part A. This is the left-hand side, this is the right-hand side. So this is definitely not going to work. For part B, is 1 squared plus 2 squared plus 3 squared the same as 1 plus 2 plus 3 all squared? That is a no-no as well. For part C, is this the same when we start at 0? So we're going to get 0 squared minus 1. So we could get 0 squared, I'll go leave it like this, 0 squared minus 1 plus 1 squared minus 1 plus 2 squared minus 1. So this will not be equal as well. Because we will end up with minus and 1 right through, and we wouldn't end up with we will still end up with the 1 squared plus 2 squared plus 3 squared plus 4 squared, but we will have to minus 1, then minus 2, then minus 3, and so on. So we're going to have to take away something from the original summation, which is not what we want. So the last one, when I split up the summation, this here is going to be 2n. And when we plus the summation, this remains as the summation of r squared, so D is my answer. Which of the following are factors of this? So all we have to do is plug in the values directly into the equation. So I will plug in, now part 2 looking like the easy, I want to plug in. So let me just plug in x is equal to 1. So for each one, x is minus 1, x is 1, x is minus 2. Four into 1, I'm putting the 1, which is going to be 4 plus 8 minus 2 minus 6 minus 4 is 0. So 2 is indeed an answer. So if 2 is an answer, this, and this working. So let me just check now for the, let me check for the minus 1. So 4 into minus 1 squared going to give me 4. Minus 1 cubed go give me minus 1. So that could be minus 8. Minus 2 by minus 1 squared remains as minus 2. Minus 1 squared will be positive 1. Minus 6 by minus 1 is plus 6. And minus 4. So 1 is not an answer. So if 1 is not an answer, this, and this going out of the window. So the answer is going to be C. Two roots of the cubic equation are minus 1 and minus 2. The third root is, let me see if we can solve this on the calculator now. More than likely it will be able to be solved, right? 2, 3 minus 5 minus 6. Alright, so minus 2 is our answer. 1.5 is our answer. And minus 1. So 1.5 is the same thing as 3 over 2. That's the third root. 3 log 2q to the base 2 minus 2 log 3q to the base 2 plus 1 expressed as a single logarithm in its simplest form is... Alright, so I'm going to move the 3 as a power. I'm moving the 2 as a power. So I'll get log of 2q all cubed, take away log of 3q all squared, plus log of 2. Right? All the bases are 2. So using the laws of logs, I'm going to get 2 to the power 3 is 8. So I'm going to get log of 8q cubed divided by 9 q squared multiplied by 2. So the q and the q goes away. 8 by 2 is 16. So I'll get 16q over 9 to base 2. The answer is A. Alright, the statement if not P and not P or Q is logically equivalent to. Now I told you guys this previously, right? Let me hope and pray that one of these questions repeats, because using the algebra of propositions, using De Morgan's laws and so on, it's going to be bacchanal. I most believe this is a repeat question where the answer for this is indeed D, but we go still check it and see. So this particular answer, just remember what it is. The answer is not P and not Q. What they can do, if they bring it as a repeat, they can always change the position of the answer. We know it's D in this particular paper. I think it was D as well in 2018. So I will just put this here, repeat from 2018, if you all want to see the working for it. A circle is defined as x plus 2 all squared plus y squared is equal to 4. The gradient of the normal to the circle at 0, 0 is, so the gradient of the normal is going to be the gradient of the radius. So let me get the center of the circle. The center of the circle going to be x minus minus 2, which is going to be minus 2, 0, that is center. And 0, 0 is the point on the circle. So if we were to make a quick sketch of this, right? Because we have the same y coordinate, 0, 0 is here, minus 2, 0 is over here. So this particular radius is going to be a horizontal line, which will have a gradient of 0. Express sine 6a plus sine, the expression sine 6a plus sine 4a may be written as, so this is where remembering your identities for trigs, for those of you all who don't like it, this method is going to be useful. Let a be something 5.89623, and I'm going to store that in literally the slot A. So let me see. It don't matter what the measure your calculator is in, whether it's degrees or whether it's radians. Sine 6a plus sine 4a, sine 4a is 0.9. I'm writing this down. 0.979067156. Let me see what sine 10a is. No. What is negative 2 cos 2a? No. 2 cos 5a sine a. No. It had to be 2 sine 5a cos a. So we just double checking. Yes, it is. So the answer is D. Um, 8 sine theta minus 5 cos theta has a minimum value of, minimum value is the y value, and we just need to combine this in the form r cos theta plus alpha, and r will determine the maximum and the minimum value of the function. So we know if you go through the working, all you have to do is square the 8, square the 5, or the minus 5, square root it, and that is going to give us r. 64 plus 25 89. Square root of 89 is going to be r. So r is going to be, the minimum is going to be the negative part, the maximum is going to be the positive part. So negative root 89 is the answer. The relationship between the curve and the line is that the line, oh good. Well, boy, I just going to solve this simultaneously because they try and logic out A, B, C, and D go be real taxing on my brain. If y is equal to 2x, 2x is x squared minus 2x plus 4. So x squared minus 4x plus 4 is equal to 0. This is a perfect square. This is x minus 2 all squared is equal to 0. And I get in one answer. X is equal to 2. So this line is a tangent to the curve because it's cutting the curve at one point, or it's touching the curve at one point, right? So it touches the curve at the point 2, 4. So when x is 2, y is 4. So C is the answer. A curve is defined by the parametric equations x and y. The Cartesian equation of the curve. So this is yet again a repeat question. I can't remember what the answer is, but to do the solutions for this, not that difficult. From here, t is equal to y minus 2. Throw that inside a day. X is equal to 3 plus 2 into y minus 2. Watch the format of the equations. We have the x, then the y, and then the equal. So we're going to do that. X is equal to 3 plus 2y minus 4. I'm looking at x minus 2y is equal to something. D is the only option that has x minus 2y. Let me just entertain it. 3 take away 4, minus 1, minus 1. So we got to go here. Given that the position vectors of points P and Q are this, respectively, the length of the vector PQ is, so PQ is equal to negative OP plus OQ, which is minus 2, 1, minus 8. That is negative OP. Minus 1, 4, 4. So PQ is going to be minus 3, 5, minus 4. And I want to get the length of this vector. So I'll jump on my calculator very, very quickly. 9 plus 25 plus 16 square root of 50. How can I break down the square root of 50? So root 50 is root 25 root 2, which is 5 root 2, which is B. The expression cot x plus tan x can be written as, so cot x is going to be cos x over sin x plus sin x over cos x. We go get cos squared x plus sin squared x over sin x cos x, which is 1 over sin x cos x. None of the answers we have are 1 over sin x cos x, so we'll use the double angle formula for sin 2x is 2 sin x cos x, and sin 2x divided by 2 is going to give me the sin x cos x. So I'll get 1 divided by, instead of sin x cos x, we're going to have sin 2x over 2. So it's 1 multiplied by 2 over sin 2x. And that's going to be 2 cosec 2x. So the answer for this is A. Alright, so this is our repeat question. And so far, over all the years that we will do, 23 is one of the repeat questions exactly as it stands. Alright? And the answers, I believe, is, I think the answer for this was B. And let me just solidify that by doing over the working, right? So if sine 2 theta is sine of pi on 6, then 2 theta is going to be pi on 6. Alright? Well, 2 theta is going to be n pi plus minus 1 to the n pi on 6. And theta is n pi by plus minus 1 to the n pi on 12. When n is an even number, I'm going to get n pi plus pi on 12 is theta. When n is odd, I'm going to get I'm going to get 2n plus 1 pi minus pi on 12. So we will get 2n pi plus pi minus pi on 12. So 12 over 12 minus pi over 12. We get 2n pi plus 12, 11 over 12. Sorry, 11 over 12, 11 pi on 12. No, it's supposed to be 5 pi on 12. Right, I know the answer is B. So, I mean, I'm doing it real shortcutty here, so let me just do it properly on the side. So, we know that our 2 theta is equal to n pi plus minus 1 to the n multiplied by pi on 6. So, theta is equal to n pi over 2 plus minus 1 to the n by pi on 12. So when n is even, I'm going to get theta is equal to 2n pi on 2. The 2 and the 2 cancel, so I'll remain with n pi, and I'll remain with plus pi on 12. So we get the first part of my answer, which is n pi plus pi on 12. That's the top piece. When n is odd, I'm going to get 2n plus 1 pi over 2. That is what I was missing out in the shorthand where I was doing just now. Plus minus 1 to the n, minus pi on 12. So we get 2n pi over 2 plus pi over 2 minus pi over 12. So multiply this by 6, multiply this by 6. I'm going to get 6 take away 1 is going to give me 5 pi on 12. So we're going to get n pi plus 5 pi on 12. So yes, the answer is indeed B. Vector u has a magnitude of 4 root 5 units and is parallel to the vector v, a unit vector. So we're looking to see which one of these are going to be unit vectors. And the only one that will give us a unit vector, a modulus of 1 or a magnitude of 1, is going to be part D. So again, yeah, part D will be the only question, the only solution that gives us a magnitude of 1. The magnitude of this, and this will be more than 1. The variable point P moves so that it is the same distance from the point 1, 6 and 3, 2. The equation of the locus of P may be obtained by, alright. So let me go through the full working for this one here. I can rub off this because I'll already see the solutions for them. So if I let this point be A and I let this point be B, PA is equal to PB. So PA is going to be the square root of x minus 1 squared plus y minus 6 squared. And PB is going to be x minus 3 squared plus y minus 2 squared. And looking at the answers, C is the answer, right? Not that bad. The circle with equation that cuts the circle with equation that at 2 distinct points. The equation of the common chord is, so one time I'm going to take away these 2 equations from each other. Alright? The x squared and the x squared, the y squared and the y squared takes away. I'm going to get minus 2x, take away minus 8x, which is minus 2x, plus 8x, which is 6x. I'll get minus 6y plus 8y, which is plus 2y. I'm going to get 1, take away 31 is minus 30 is equal to 0. I'll divide everything by 2. 3x plus y minus 15 is equal to 0. The answer is C. The cosine of the angle between the vectors. This is a repeat question. I most believe the answer for this was 1 over root 2. Because A dotted with B, we will get 0 minus 6 dotted with 1, 1 is going to be minus 6 is equal to root 36. Well, it will be root 36, which is 6, multiplied by root 2 cosine theta. So minus 6 divided by 6 root 2 will be minus 1 over root 2. So I was wrong. The answer for number 27 is A. The set of values of k for which a straight line intersects the curve with equation y is equal to x squared minus 2x at two distinct points is. Let's go ahead and solve them simultaneously and solve for k. So substitute 1 into 2. I'll substitute 2 into 1. That'll be a little easier. X squared minus 2x is equal to kx minus 4. X squared minus 2x minus kx plus 4 is equal to 0. X squared plus minus 2 minus k x plus 4 is 0. B squared minus 4ac for two distinct points is greater than 0. B squared minus 4ac is greater than 0. Minus 2 minus k squared is 4 plus 4k plus k squared minus 16 is greater than 0. K squared plus 4k minus 12. And I'll put in equal to 0. We have a positive coefficient, so is this greater than 0 is here and here. So it's the union of two separate sets of values. And let me go ahead and solve for k. So quadratic calculator, 1, 4, minus 12, 2 and minus 6. So this is minus 6, this is 2, less than minus 6, greater than 2. C is the answer. This one is 386. Trying to jog my memory a little bit here, right? I believe this is 386, but we're still going on confirm. Still going on confirm. So nice. 3a is going to be minus 921, and 2b is 2 to the 4 minus 2. 3a plus 2b minus 9 plus 4 is minus 5. 21 plus minus 2 is 19. So 25 plus 19 squared, 386, and is the magnitude, so we're calculating the square root of that. The path of an object is given parametrically as x is equal to sine t plus 2, y is equal to cos t plus 1. The slope of the tangent at t is equal to pi on 4 is, alright, so dx dt is cos t. dy dt is minus sine t. dy dx is dy dt multiplied by dt dx. So it's going to be minus sine t divided by cos t, because I have the x dt and I want to get what dt dx is. So I just flip in it, right? And from here, you don't even have to do anything fancy. We know that how this is minus tan t, and when t is pi on 4, minus tan of pi on 4 is going to be minus 1. Y is equal to 2x minus 1 to the power 4. dy dx is equal to 4 multiplied by 2 into 2x minus 1 cubed. And the second derivative is going to be 8 by minus 2 into 2x minus 1 squared. Sorry, 24 by 2. Yeah, 8 3s are 24 and differentiate. Nice. 24 by 2 is 48, so the only one that has 48 is D. And 2x minus 1 squared, if I square root this and I square root this, 2x minus 1 squared is going to be root y. Alright, so let's check and see if it is indeterminate first. The denominator is minus 2, so it's not indeterminate. So the numerator will be minus 1 squared, which is 1, minus minus 1, which is going to be plus 1, minus 2 over minus 2. The numerator is 0, so this limit tends to 0. Which of the following real functions has a point of discontinuity? Well, we know that when we have a denominator, we can solve for the where the function doesn't exist. This one here, we wouldn't get no answers because x squared is equal to minus 1. Those are complex. This one, it doesn't have a point of discontinuity here. The graph just doesn't exist for less than when the square root is less than 0. Over here, he exists everywhere. Over here, he doesn't exist when x is equal to negative 1. So the answer is D. If the point A lies on the plane, then the value of the constant D is, we'll just plug in the x, the y, and the z. There's x, there's y, this is z. So we're going to get x minus 2y plus 3z. So 3 plus 2 plus 6, we're going to get 11. Alright, so all the denominators are the same, right? 3x minus 4 squared, 3x minus 4 squared. Good. So I just concerned with the numerator. I know it's going to be minus 21, but we're going to show it, right? This is u, this is v. We're going to get v by du dx minus u by dv dx all over v squared. I know we have v squared already. 3x minus 4. Why put 3x minus 3 minus 4x? Sorry. Alright, don't be wrong. So we're going to get 3 minus 4x plus 4x minus 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 is minus 24. So 4x and 4x goes. 3 take away 24 is minus 21. The volume of the solid generated when the area enclosed by the curve y is equal to x squared. The y-axis underlying y is 4 y is x squared. The y-axis underlying y is 4. Okay, so 0 is a lower limit. So we're going to get the integral of pi x squared dy, which is between 4 and 0. So we're going to get pi x squared is y. So we're going to get, I'm doing the working downstairs here, pi y squared over 2 between 4 and 0. I just plug in the upper limit because when I plug in 0, I'm going to get 0. 16 over 2 is 8, so the answer is 8 pi. A curve is defined by the equation y is equal to minus 5 into 1 minus 2x. Given that x increases at a rate of 1 unit per second when x is equal to 1, what is the corresponding rate of change for y? So we want dy dt. Ooh. X increases at a rate, so dx dt is equal to 1 unit per second. We want to get dy dt. Dy dt is dy dx multiplied by dx dt. dy dx is going to be minus 10 multiplied by minus 2 for the differential of the brackets, which is going to give me 20 into 1 minus 2x multiplied by 1. And we're going to get 20 take away 40x. When x is equal to 1, 20 take away 40 is going to be negative 20. So the answer for this is negative 20. So this one would be a little bit tricky reading it at first, because you're going to think you want to calculate dy dt by differentiating something in terms of t. Alright, this is a repeat question. The answer for this is definitely plus or minus a quarter. So we're going to get 16x plus x to the minus 1. 16 plus x to the minus, 16 minus x to the minus 2 and put it equal to 0. So we're going to get 16 is equal to x to the minus 2. 16 is 1 on x squared. 1 on 16 is x squared, and so on. Tralala. Square root thing. Plus or minus a quarter. 39 is also a repeat, but we will still do it. U and v. V by du dx plus u by dv dx. Factorize all the x squared into 3 sine x plus x cos x. 3 sine x plus x cos x. The answer is C. This is a repeat without any fail, any uncertainties. D is the answer. Because when we use the identity above, we are going to get, let x be x on 4. This one was indeed a cosine one from the repeat, right? If I'm not mistaken, it'll be cos 2x is 2 cos squared x minus 1. Then the integral of cos squared x plus that. Let me check back and see, right? I must believe that's a repeat. Number 40's territory. Yeah. Yep, a half x plus a half integral cosine x on 2. So from 2018, this was the repeat. The gradient of the normal to the curve y is equal to ln x at x is equal to 2 is, so the gradient of the normal. So the gradient of the tangent, when I differentiate ln x, I get 1 on x. When x is 2, I get a half. That's the gradient of the tangent. The gradient of the normal is going to be minus 2. The radius of a circle is increasing at a rate of 0.1. When the radius is 3, the rate of increase of the area, the a dt, is the r dt by the a dr. If a is equal to pi r squared, 2 pi r is the a dr. The r dt by 2 pi, and the radius is 3. So we get 0.6 pi. And 0.6 is 6 over 10, which is going to be 2 into that is 3/5. 3/5 pi. If the rate of change of y with respect to x is that, then y is equal to, we have to integrate this. So the telling dy dx is this. So we integrate in 3x squared plus 4x to the minus 3. 3x cubed on 3 plus 4x to the minus 2 over minus 2. X cubed minus 2 over x squared. X cubed minus 2 over x squared. The answer is C. Alright, this one here, L'Hopital. When I differentiate the top, I get 3x squared over 1. Plug in x is 2. 3 into 2 squared is 4. 12 is the answer. The gradient of the normal to the curve at x is 1, so dy dx is going to be 6x minus 2. When x is 1, the gradient is 4. That the gradient of the tangent. The gradient of the normal could be negative a quarter. And that's it for 2020.